In this video, I'll present the paper titled MASH, Scaffolding Comparison Tables for Online Decision Making. My name is Joseph Chang. This paper is joint work with Nathan Hahn and Aniket Kittur. So exploring information online is how many of us make sense of the world today. We browse the internet to support all kinds of decision making, from things like who should I vote for, what neighborhood should I live in, to which desk lamp should I purchase. This work explores ways to support online decision making in the domain of product comparison research. So let's imagine you go on Amazon and try to find the right desk lamp for you. Immediately, you get these hundreds of different options in your search result. Each of them have hundreds to thousands of reviews, and many of them were highly rated. So you might start by clicking on this first option. Now you're on the product page, and as you read the descriptions and reviews, you start to pick out interesting criteria that fit your personal context. So things like some of them support glare reduction, or whether it has USB outlets for charging your devices. Some of the criteria might require you to read many reviews to get a better sense of how well this option performed. So here you see there's a bunch of reviews mentioning that this one can flicker, which seems pretty bad. At this point, you picked up a set of criteria that you care about, and you have a pretty good sense of how well this first desk lamp fits your goals. But when you go back to the search result, you still have all these different options that you need to figure out. Ideally, you want something like this, a comparison table with all the options compared using all the criteria that you picked up through your exploration. This allows you to see clear trade-off and make purchase decisions. But in reality, the process looks more like this. To characterize each of these options, you need to click into each of them, read a bunch of reviews and descriptions to figure out how well it fit your personal context. Now, there are many top-down approaches that help with this process. So things like making a direct product recommendation, review ranking and summarizations, or interfaces that allow you to navigate across different type of options more efficiently. But fundamentally, users still need to take a bottom-up approach in many cases, figuring out what criteria are useful for them, and reading reviews and information across different sources to make up their own minds about these different options. So what tools do people currently use to support these online comparison research? We did a survey with 89 participants, and we found that around half of them built spreadsheets in the past to help them keep track of their online decision making. So here's one example of what these type of spreadsheet might look like. This one is a spreadsheet for comparing different espresso machines. You can see basic product information on the left, like price and model names. And then there's some objective facts about these different machines, like specifications. And then you have these more subjective notes on the right for things like the design or whether it is easy to adjust and use. So about half of the participants said that they've created spreadsheets like this in the past. We interviewed 30 of them, each for 60 minutes. And then we came up with 3 high-level design goals. Firstly, we found that people want to compare multiple options using the same set of criteria. But they also pointed to how switching back and forth between browser tabs and spreadsheets to compare their options is a pretty frustrating process. Secondly, they emphasize on the importance of seeing raw evidence instead of just aggregation. So instead of seeing just the average review ratings, they want to read reviews so that they can make up their own judgment, make up their own mind and make their own judgment on these individual pieces of evidence. And thirdly, they want to work in a more organized fashion, describing their current process as chaotic or often falling into rabbit holes, pointing to experiences where it could be hard to keep track of their overall progress and focus on the important criteria that they set out to investigate. So based on these design goals, we came up with a Chrome extension called MASH. When you open MASH, it recognizes all the Amazon product pages you have open in users' browser tabs. This allowed users to import them into a project, and it also allowed the system to fetch product information and reviews from Amazon. After importing, options are shown as columns in the table. Then users can also add additional online sources about each product by pasting in URLs. So to minimize the effort for comparing different options using the same criteria, users can create criteria in their tables as roles. The system will in turn fetch reviews that mention the criteria name for each option and show the average rating as the default values for the cells. Users can then click on a criterion to see relevant evidence side by side for each option. This included reviews, product descriptions, and sentences from the additional sources that contain the criterion name. Based on examining this evidence, users can then overwrite the default ratings with their own and also take short notes to record their options from investigating and reading these evidence. As the users explore more evidence, they gradually build up a comparison table that contains their own options and criteria, and also how they interpreted evidence to characterize each options in this more organized way. To help them better compare their different options, they can now then reorder or sort their options based on the ratings of each criterion. They can also assign weights to their criteria, and the system will calculate a weighted average rating in real time. So that was a high-level walkthrough of the system. There's more details in the paper. But does it actually work? So for evaluation, we conducted 3 studies focusing on 3 different aspects. Study 1 focused on interaction, where we wanted to figure out if users can be more efficient using the tool. Study 2 focused on learning. We wanted to figure out if users can learn more insights from data using the tool. And finally, for study 3, we conducted a field deployment where participants installed MASH on their own computers and conducted their own real-world tasks for a prolonged period of time. So starting with study 1, we wanted to investigate how quickly and accurately users can find answers using MASH. So to measure this, we gave them a blank table with fixed options and these objective criteria that had gold standard answers. So the task we used was to fill out these criteria for espresso machines, which included things like the dimensions of the machines and the water tank sizes of the machines. We used a within subject baseline condition, where we turned off the feature that automatically gathered evidence across different sources. So the baseline condition is similar to users' current process, where they have to browse the Amazon product pages or search directly on Google or other search engines to find answers for these product specifications. And in the system condition, they see relevant evidence that the system pulled in from different sources, but they also have to learn this new and unfamiliar interface during the study. So here are the results for study 1. The red bars were from the baseline condition, and the blue ones were from MASH. At a high level, participants found significantly more correct answers while using MASH. It also took them significantly less time to find those answers. More surprisingly, based on the NASA TLX questionnaire, they actually perceived using MASH as having a lowered workload, even though they had to learn this whole new interface that they're not familiar with during the study. So this first study sort of tested the usability of the interface and found that participants can work more efficiently for these objective criteria that had correct answers. For the second study, we look at criteria that were more subjective and experience-based. So this task can be more challenging for the first one because participants have to look at multiple reviews to better characterize each criteria for each options. To control for task complexity, we used a fixed persona for buying a robot vacuum. The persona had 3 criteria that were more subjective and experience-based. Included that the model should not get stuck too often. It should not be too loud. It also should be effective when cleaning up dog hair. So I also gave each participant 5 fixed options that were all highly rated on Amazon with hundreds of reviews. For the baseline condition, we compared MASH to Google Spreadsheet as a between subject condition. Google Spreadsheet is a tool that people commonly use to support this type of research based on our preliminary survey. So we had participants each conduct 20 minutes of research using their assigned tools, and then write a short summary of what they've learned during that 20-minute period. So this is a common practice for evaluating these research support tools to try and capture how well people have learned in a fixed amount of time. We then rated each of the learning summaries on these 4 aspects. The first one was how relevant it was to the persona. This is based on how participants in the preliminary interview said that they sometimes get lost in the research process and it can be difficult for them to focus on the important criteria that they set out to investigate. The second one was how insightful the summaries were. This aimed to measure the amount of information that they've learned in that 20-minute time period. The third one was confidence, which we used as a proxy for measuring how well it can support decision-making. And then the fourth one was usefulness, which we use as a general quality control measure. So each of these was rated using a 7-point Likert scale for agreement by 5 crowd workers. And then we took the average as the final score for each aspect. We also showed the crowd workers the same persona that we used in the main task when they were rating the summaries, but they were blind to which conditions generated each summary. So here are the results for study 2. The red bars, again, are from the baseline condition, in this case, Google Spreadsheet. Overall, participants who used MASH generated summaries that were rated significantly higher on these 4 aspects. This suggests that the approach of scaffolding these comparison tables allowed participants to focus on the important criteria in the persona that we gave them and allow them to gain deeper insights from data during that 20 minutes of research. So here are 2 example summaries that were representative of the 2 conditions. The one on top is from the baseline condition. You can see here the summary focused more on how all of the options were very similar and highly rated, and it can be difficult to tell them apart. Whereas the second one from a participant who used MASH, this person was able to point out meaningful differences that he or she saw in data. So the first 2 studies were lab studies where we controlled for task complexity using fixed options and criteria. To test MASH in a more realistic setting, we deployed the system for 2 weeks to 5 participants in study 3, and then to collect more qualitative insights. You can see in the table that they've conducted a wide variety of shopping tasks, ranging from clothing, appliances, cat food, furniture, and more. Each of them were interviewed for 1 hour initially and then 1 hour after the deployment. We then coded the transcripts in 3 passes using a grounded theory approach. So before I get to the themes from the interviews, we also collected usage statistics. The details are in the paper, but the main thing here is that all of them spent a significant amount of time in the systems and were all actively engaged using all the different features. So there are many interesting quotes in the paper on their strategies and how they benefited from the system. In the interest of time, I will go through 2 main themes. The first one, all participants described how MASH allowed them to take a more organized and structured approach, which was one of the 3 design goals we set out to support. They also mentioned a lower interaction cost when managing multiple information sources and consuming evidence from them. 2 of the participants specifically mentioned how the table structure is more suitable for this type of online research when compared to the linear structure of browser tabs. 4 of the participants made actual purchases within the 2-week study period, showing that these tasks that they were conducting were realistic and people can use MASH to support making that final decision. Many participants also compared MASH directly to using a spreadsheet. Here's one of those quotes. Pause the video if you want to read it. The second most common theme was that participants talked about using the default star ratings to prioritize their research efforts. So this is the yellow stars that show up immediately after they create a new criteria row in the system. They describe using it to focus their investigation on criteria that had large discrepancies between their options. This potentially allowed them to rule out more options earlier on in the process and shortcut their research process. They also describe how these default ratings allow them to see meaningful differences between all these options that can be very difficult to differentiate on Amazon because they all had very high average ratings. Finally, they also talked about how using their existing criteria in the system can allow them to quickly evaluate newly added options that they were considering. Here's one example project from one of the participants. You can see that there were multiple options and criteria. Some of the ratings were replaced by the user's own personal ratings. There was also notes in different cells. So to conclude, online decision-making can be challenging. One reason is that evidence are often scattered across different browser tabs, and they can also be biased, subjective, and conflicting. In these scenarios, users often need to compare multiple information sources and make their own judgments about data. So for this, we introduced MASH, a system where users iteratively build up a comparison table by discovering options and criteria as they explore evidence. The system was based on 3 design goals that we developed with an exploratory interview. We conducted 3 studies showing that MASH can allow users to work faster, more accurately, and with a lower perceived interaction cost when figuring out objective criteria. We also showed that when they were working with subjective criteria, they were more insightful and more confident during a 20-minute study. And finally, we conducted a field deployment study showing that people can use MASH to conduct real-world tasks, and they also benefited from using and showed the ways they benefited from building up these comparison tables and making that final purchase decision. So finally, we show that Providing better scaffolding support, in this case, creating these comparison tables, can benefit users not only by lowering interaction costs, but also allow them to gain deeper insights from data to support online decision-making.